Hello. So, in this video, we will go through chapter 16 in class exercise 2. This is the problem from absolute motion analysis for rigid body for general plane motion. So, let's read the problem statement. At the instant shown, angle theta is 60 degree and rod AB is subjected to a deceleration of 16 meter per second square when the velocity is 10 meters per second. Determine the angular velocity and angular acceleration of link CD at this instant. So this is a slider crank mechanism where link CD is the crank and link AB acts as a slider. This is the general plane motion because link CD undergoes rotational motion while link AB undergoes translation motion. For this problem, we define that anything that's going left is positive. That means the velocity of link AB is positive, but acceleration is negative because it's going right. For rotational link, our assumption is anything that's counterclockwise, rotates counterclockwise is positive. And that means if something going clockwise, it's negative. For this problem, we select the point D as a reference point. So with respect to point D, we define the position of link AB using variable x. So x distance changes when AB slides when the link CD rotates. Similarly, for the position of link CD, we use variable theta, which defines the angle of link CD with respect to the horizontal line. So the way this mechanism works is that when link CD rotates, let's say it rotates clockwise, the link AB slides on left. And when link CD completes the other half, when link CD goes counterclockwise, then link AB moves from left to right. What we know is we know the velocity of link AB and acceleration. We need to calculate angular velocity and angular acceleration of link CD at the given instant of theta is equal to 60 degrees. So angular velocity of link CD is omega, which is nothing but theta dot, which is also can be represented as d theta by dt. And angular acceleration of link CD is alpha CD, or it's theta double dot, or d theta, d square theta divided by dt square. So we need to determine these two parameters, that is theta dot and theta double dot for link CD. In order to do that, we have already established our coordinate system. Now the next step is we need to establish the relation between this variable x in terms of angle theta using the given dimensions. So this dimension of the link is 300 millimeter. So let's convert this into meters. So let's call it 0.3 meters. And this is also 0.3 meters. This angle is also theta. So x can be written as 0.3 cosine theta, which is half of that, plus 0.3 cosine theta, which is other half. So the length x can be represented as 0.3 cosine theta. This is coming from link CD while projecting link CD onto horizontal line, plus 0.3 cosine theta. This one is coming from link BC while we project link BC onto horizontal line. So it's this segment plus this segment, that is the length of variable x. So x can be written as 0.6 cosine theta. Let's call this equation number 1. Now, if we take the first derivative of this equation, then we will relate the velocity of link AB, that is x dot, with theta dot. So let's do it. So taking first derivative of equation 1. So this will be now x dot, and this derivative is with respect to t. So this is 0.6. Derivative of cosine theta is minus sine theta, but then theta is also function of time. So we have to multiply this with the derivative of theta, which is theta dot. I further simplify this. So now it's minus 0.6 sine theta multiplied by theta dot. I put the multiplication sign here. So now in this equation, we know x dot is the velocity of link AB, which is 10, and it's going left, and we assume that anything going left is positive. So this is 10 is equal to minus 0.6 sine, value of theta is 60 degree because that's given in the problem, the first line, multiply by theta dot. So when we solve this equation, we get theta dot is equal to minus 19.24 radians per second. That is the angular velocity of link CD, and the negative number also matches with our assumption that it's going clockwise. Okay, and this you can see in the graph as well that when AB goes left, then CD has to go clockwise. Then only it's possible. So that's our first answer. For second part, okay, let's define this as our equation number 2. Now to calculate acceleration, we have to take one more derivative of velocity. So taking derivative of equation 2 with respect to time. So when we do that, we'll get x double dot is equal to minus 0.6. Now there are two terms here and both are function of time and they are in multiplication, so we have to apply chain rule. So first we take the derivative of sine theta, which is cosine theta, multiply that with the derivative of theta, which is theta dot, and there is already theta dot in the equation, so it stays as it is, theta dot. Then plus sine. Now we will keep the sine theta constant and take the derivative of theta dot with respect to time, so that it will be theta double dot. And that's our equation. So in this equation, we know everything except theta double dot. We know x double dot, which is given, and 16, and it's going right, so that number is negative. So it's minus 16 is equal to minus 0.6 cosine 60 multiply by, this is theta dot multiply by theta dot, so it is theta dot square, and we have already calculated theta dot, which is 19.24. So it's minus 19.24 square plus sine 60 degrees multiply by theta double dot. When you solve this equation, you will get the value of theta double dot, which will be positive 130.04, and the unit is radian per second square because this is angular acceleration. And this number is positive, that means the direction of theta double dot is counterclockwise. So our final answer is omega CD is theta dot CD, which is 19.24. And now I write the positive number here, but then I indicate the sign using the arrow, and this is clockwise. Okay. And then we have alpha CD, which is theta double dot CD, which is 183.04 radians per second square, and this is counterclockwise. And these are our final answers. Now also pay attention to the sign here that alpha CD is clockwise, and omega CD is clockwise and alpha CD is counterclockwise. Now acceleration has sign opposite to that of velocity. That means link CD slows down. So let me write it here. So CD slows down, okay, as time passes. And that's why the acceleration is opposite to that of angular velocity.